Good morning, good afternoon, and good evening. My name is Mohan Gundu. I'm the Vice President of IoT Applications at Veea, and today I'm joined by Kennet Garcia Oviedo, CEO of Trionix. Welcome to the workshop. Today we would like to show you an interesting application of LoRa technology for an underground tunnel system. 4 months ago, we were approached by a leading vendor of industrial fans in Latin America. They produce these massive fans that are used to ventilate the tunnels. They have an existing system that works, but it requires laying cables across the tunnel, connecting the sensors and other equipment. The system is very hard to deploy and takes long time to deploy, and it is very expensive to operate. And when things go wrong, it takes long time to troubleshoot as well. Working with our partner Trionix, a system integrator from Mexico, we built a much simpler system based on LoRaWAN. The system runs on Veea Smart Edge nodes. The POC was designed and built in less than 1 month, and we are planning to deploy this solution this quarter. A tunnel ventilation system is a complex control system. It needs to take data from multiple factors, things like external environment factors as measured by the weather stations at each end of the tunnel. You need to take into account the effects of the moving vehicles inside the tunnel, temperature, humidity, air quality, and other data inside the tunnel. And you also need to factor the state of other equipment. Taking all of these things into account, you need to come up with an optimal way to manage the tunnel, providing clean air and also regulating the temperature and supporting the emergency evacuation procedures. We proposed a three-phase approach to our customer. The first phase involved monitoring of the motor bearings from a distance. As I said, these facilities are 100 or 150 meters away from the tunnel. In the second phase, all the sensors inside the tunnel will be replaced with Trionix sensors across 1.5 kilometer tunnel, and the data from these sensors will be used to control the operations of the fans and extractors. In phase 3, the existing system will be replaced by a offsite management dashboard that can be operated right from the edge location near the tunnel, or it can be operated remotely from the cloud as well. Before I get into the details about this particular solution in detail, let me talk a little bit about what Veea is and who we are. Veea was formed by a wireless industry pioneer, Alan Salmasi. Alan led and initiated the development of mobile handsets and chipsets at Qualcomm. And after his illustrious career at Qualcomm, Alan founded NextWave, where they developed the very first mobile virtual network operator. Alan founded Veea with an idea to simplify building edge applications. We are headquartered in Manhattan with major development centers in UK and New York and New Jersey area. Veea provides integrated solutions for edge compute, connectivity needed at the edge, and securing all of those elements. If you think about building an IoT application, you will see that there is complexity at every stage. First, you need to research and find the right type of hardware, the usual things that you need to worry about, the number of cores, memory, storage, etc. But invariably, edge applications need to connect to various devices. What type of IoT radio technology that I'm going to use? Bluetooth, Zigbee, LoRaWAN. What about the scalability? If I need to scale this application, how am I going to design it from a hardware standpoint? Is it going to be an indoor application or an outdoor application? Once you have the hardware figured out, you need to think about the software side as well, right? What languages to write these applications in? How do I secure my applications? What are the protocol stacks that I'm going to use for LoRa, Zigbee, Bluetooth, and variety of other technologies that you need to integrate. If you have a multi-box solution, you need to think about system integration as well from a software perspective. Finally, once you have hardware and software, How do you manage this system if you have thousands of these devices at the edge and hundreds of thousands of sensors? How do I manage the entire thing from an end-to-end perspective? How do I deploy the applications? How do I provide OTA updates? Veea provides to simplify this with Veea Edge Platform. It starts with what we call as a smart edge node. A smart edge node combines the capabilities of multiple equipment type. It replaces an edge server like from a Dell or HP. It has all the functionality of various access elements, a mesh router, IoT gateways. Typically, you have IoT gateways for LoRa separately, Zigbee separately, and also it provides 4G and 5G WAN access and failover. We have storage built in, and you can expand the storage up to 2 terabytes as well. And of course, security is fundamental to the smart edge node. So we have built-in features for wireless, VPN capabilities, and SD-WAN functionality. As a result, with a smart edge node, you need fewer boxes to deploy, operate, and manage. You have few vendors to work with. Overall, you have a much less complex system. Veea Hub smart edge nodes come in multiple sizes and price points. We have our lower end model for SMB and SOHO markets. We have a model for enterprise and another one for outdoor environments. These Veea Hubs meet all of your connectivity requirements for IoT, Bluetooth, LoRa, Zigbee. We support WAN through either fixed wireless or 4G or 5G. The Veea Hub architecture allows multiple Linux compatible applications to run simultaneously on the same device. You can build your own applications with Docker compatible containers and connect with other edge services that are provided out of the box on Veea Hubs. Coming to software, we provide Veea Hub Toolkit, using which you can build applications based on standard Docker containers. IoT Toolkit lets you integrate any standards compliant IoT devices. You can bring your own devices. The IoT Toolkit provides the APIs and drivers to discover, communicate with the devices. We provide a very innovative technology called VBus to provide IoT mesh capability, using which you can transparently discover and access the devices. We have tight integration with Microsoft Azure IoT technology. Veea Hub is Azure IoT Edge certified. What that means is you can run IoT Edge modules from the Azure marketplace, or you could build your own IoT Edge modules to work with Azure's IoT Hub and IoT Central technologies. Now coming to LoRaWAN, LoRaWAN gateway bridge and network servers are supported out of the box for very simple integration. As a system integrator, you would need to focus on just building your LoRa application. The Veea Hubs can be meshed together to increase scalability, to connect either many LoRa devices. If one Veea Hub is not able to support all the LoRa sensors that you need to connect, you can mesh them together, or you can add the Veea Hubs for compute capability as well. Essentially, as a system integrator, you just need to focus on your custom application that you need to run at the edge. There are multiple options for building LoRa applications. As I said, we provide LoRa stack out of the box. Your application could run in the cloud and connect to the LoRa stack through the APIs and receive the data through MQTT. Or you could have a hybrid application where you do some of that processing at the edge and pushing the intelligent data to the cloud. Or you could run the entire application on the Veea Hub itself for an air gap type of scenario where you don't have internet connectivity. So essentially, you have the complete flexibility in building your application. Now let me turn to Kennet to introduce Trionix and describe the tunnel monitoring solution in detail.
Thank you, Mohan. Well, my name is Kennet Garcia. First of all, thanks for being here with us today. I am the CEO of Trionix, Let me introduce you who is Trionix. Well, we are a Mexican company, mainly focused on the creation and deployment of IoT and Industry 4.0 solutions. How? By providing software tools, such as APIs, webhooks, and easy-to-use platforms. On the other hand, we offer a wide variety of smart wireless devices that were specifically designed for the Internet of Things and the Industry 4.0. We have already installed over 1,200 devices in more than 30 projects across Mexico and Colombia. Going deeper into the solution, the phase number one only considers the motor bearings monitoring. But what were the requirements? Well, within an industrial park, there were 5 locations with motors that needed to be monitored. We were asked to measure temperature and vibration in the X and in the Y axis. The obstacles of these projects were mainly two. Considering that the main office was located approximately 150 meters away from each motor, the distance was the first concern. The second problem is the fact that this facility has a great deal of industrial equipment, that as we may know, it is really bad for RF technologies. This is a solution we came up with in a 4-level diagram. Going from the bottom to the top, the level 4 considers 2 vibration sensors, one for the x-axis and the other for the y-axis. Moreover, a temperature sensor that is an NTC sensor. These 3 elements are wired using the diagram on the right side of your screen to the universal controller. This universal controller has digital outputs and analog inputs that are able to read 4 to 20 milliamps, 0 to 5 volts, 0 to 10 volts, pulses, frequency, and resistance. These 5 universal controllers report periodically using LoRa communication to the Veea hub, which is responsible of acquiring the data, pre-process it, and store it into a database. We provided the possibility to end users that are off-site to monitor the status of the motors by using a cloud platform that through a connection with a cloud server could request the data stored into the Veea hub. But why Veea? Well, for us, it is an excellent partner for LoRa solutions. It provides a multi-protocol approach, which means that it allows not only LoRa connectivity, but also Bluetooth, Zigbee, Wi-Fi, just for saying some. It has an app store, which provides the possibility to developers like us to deploy, manage, upgrade, and even monetize their own applications. It also allows the creation and deployment of custom solutions in order to help applications that better fit their necessities by adding, for example, additional logic or even automation. It brings a remote device manager in order to know the status of the equipment even off-site, enabling troubleshooting. The mobile app provides an easy-to-set-up flow that, for example, could get up and running the Veea hub with the Trionix application in less than 10 minutes. The deployment of this project considers 2 parts. First, the Veea hub, and second, the equipment. The Veea hub has a Trionix Manager application installed, which is in charge of managing the devices, the information, and the platform. The communication between the Veea hub and the controllers is done by using directional antennas. The device was installed in the main office, since it is the central point of the industrial park, and we use 1.5 meter antennas of 6 dBm in order to boost the RF signal. For this project, the equipment is 5 universal controllers, 10 vibration sensors with an output of 4 to 20 milliamps, and a temperature sensor. All these controllers use 75 centimeter antennas of 3 dBm. In order to enable off-site users to monitor the state of the motors, we allow any web client to use our cloud platform to retrieve information from the Veea hub using our custom APIs and webhooks. But what would happen if for some reason the connectivity fails or there is no internet? Well, we run a local platform inside the Veea that allows any user to locally manage and monitor the system that works exactly the same as the cloud platform. The phase number 2 of this project focuses mainly in the tunnel monitoring that is quite more complicated. There are multiple problems, considering the fact that the tunnels have an average length of 1.5 kilometers. The wiring is really expensive. It has difficult maintenance routines, a complicated troubleshooting, and the addition of new sensors and controllers is not even an option. The requirements of this project include the continuous monitoring of multiple sensors periodically that are placed across the tunnel, approximately 100 sensors, including anemometers, opacimeters, gas sensors, temperature and humidity sensors, just for saying some. Moreover, it required the development of an SCADA system for communication, which is in charge of getting the information from the sensors and do the control of multiple fans and extractors according to specific procedures that are periodically verified by the client. The connectivity of this project is split in three main parts. On the top of the screen, we can find one Veea hub that is in charge of acquiring all the data sent by the end devices periodically. These devices are, for example, temperature and humidity sensors, pressure sensors, or any other sensor that could be connected to our universal controller. This Veea is responsible for pre-processing and storing the data, validate the information, and authorize the connection of the devices. On the bottom, we can find the equipment focused on the control of the fans, including a VFC driver, a PLC, and an embedded system. This last one is responsible of getting commands and signals from the Veea hub and executing any procedure it dictates. The Veea hub on the middle is the main server, who is in charge of getting the information from the sensing part, analyze it, and determine what needs to be done with each one of the extractors and fans, sending this final state to the corresponding control equipment. Just as Mohan said at the beginning, the complexity of this decision-making is based on three main things. First, meteorological information. Second, the internal conditions of the tunnels and the current state of the equipment, in order to determine what needs to be done, a pollution extraction, a temperature regulation, or going to an emergency state. The main Veea hub also runs a local platform in order to allow engineers on site to know in real time what is happening, and allowing them to monitor and control the equipment. Moreover, we introduced two new elements to this diagram by sending information periodically to the AWS cloud in order to replicate this exact platform into the cloud and allow offsite managers and engineers to do the same in any part of the world. Finally, what is the architecture in a lower level inside the Veea? Well, as you can see on the bottom, we have some symbology. The dotted line refers to a Docker container, the blue color to a Trionix development, and the orange to Veea elements. The green part refers to third-party solutions. Trionix not only offers LoRa devices, but also Wi-Fi, Bluetooth, and wired devices. Therefore, going from left to right, we have any device sending data to the Veea hub. The multi-protocol data is gathered by the Veea hub and makes it visible in order to use it. The blue box marks the Trionix solution, which leverages components of the Veea SDK, such as the chirp stack or the MQTT server that we use to get the data from the sensors. The Trionix Device Manager is the software component that verifies the authenticity of the devices and their messages, providing credentials, pre-processes the information, and handles the internal and the external communication. As we can see, we have three other components into Docker containers, a MongoDB in order to store all the data, an SSH reach, and a proxy for communication with the cloud. At the top, we have the dbus API that we also use for communication with the LoRa radio. At the cloud, we have installed an SSH server and a stream replicator in order to establish the connection with the Veea hub and brings the possibility to have a cloud platform that gets information using the Internet Exposed APIs and our webhooks. Due to these tools, the application could be even a third-party development. And now it is time for a short demo. Let me show you the platform we have developed for our client. And this is it. This is an exact copy of what they currently have, with two main differences. First, we changed the logo and the background image. In the real platform, this image is one of their facilities, and these are placed in the exact location of the motor bearings. These cards represent each one motor. As we can see, they have really useful information. For example, the status, the temperature, and the vibration. As we can see, number 4 is offline. This is because they're giving maintenance to the equipment. Going deeper into the details, we can see the temperature and the vibration as well. The signal strength, that we can see, is pretty high, 86.75%. This is due to the architecture that we're using and the antennas that we're using as well. Moreover, we can have the last report that was just 1 minute ago. This is considering that this controller is reporting in a minute basis. We have more technical information, such as the identifier that is pretty useful for our client, the technology, that is LoRa, the type of the device that is a controller, the category, that is a digital universal, considering digital outputs, universal inputs, and the EUI, that is the unique identifier within the LoRa network. On the right-hand side, we have three graphs. The first one for temperature monitoring, that as we can see, it is getting warmer along the day. The second and the third for the vibration monitoring on the X and the Y axis respectively. As we can see, this motor bearing is pretty steady. Due to the requirements of our client, we needed to provide a way to download historical data. Therefore, for example, we wanted to know what happened today between 10 a.m. and 12 p.m. I will download the spreadsheet with the historical data. And here it is. Let me open it. 1 second. Here we go. So in this spreadsheet, we have the date, the hour, the temperature, the vibration, and the signal strength. They use this data in order to know what's going on with the device and what's going on with the equipment. So they have personalized statistics and analytics in order to know if their equipment needs maintenance or not. Well, with nothing more to say, I would like to thank Mohan, all the VS team, and thank all of you for letting me speak a little bit about this exciting project. Going back to Mohan in order to listen the final summary and the final takeaways. Thank you all.
Thanks, Kennet, for the details and the demo. As Kennet showed, a complex problem like a channel management system can be solved in a simplified manner using the LoRaWAN technology running on Veea's integrated smart edge nodes. You can have a peace of mind knowing that Veea's edge platform can scale as your requirements grow. As you all know, LoRa has applications across a variety of fields and industries. We can't wait to see what kind of applications you can build on our Veea Hub technology. We encourage you to become a Veea Edge platform developer. Now we'll open up for live Q&A.